Benefits of collagen active aging. Collagen, the most plentiful protein in the body, is crucial for preserving the structure and function of various tissues. It makes up about 25% to 35% of the body's total protein content. As we get older, our body's collagen production starts to decline, usually beginning between ages 20-30 and continuing over time. This decrease can be attributed to various factors, including exposure to UV rays, pollution, hormonal changes, and more. Effects on bone. Low protein intake reduces bone mineral density, particularly in the elderly. An experiment was performed to investigate the effect of collagen ingestion on low protein conditions. When a mice was given 10% casein food, it showed bone mineral density to be significantly lower compared to mice given 14% casein food. The figure shows bone mineral density of mice raised for 10 weeks, with food consisting of 6% casein, 10% casein, or 6% casein plus 4% collagen. Bone mineral density of mice who were given 6% casein plus 4% collagen was significantly higher compared to mice given 10% casein. Collagen improves bone density more effectively during protein undernutrition. Previous research supports collagen's benefits for bone density and strength. Effects on Achilles tendon. Tendons are made of arranged collagen fibrils that connect muscle with bone. Excess exercise or awkward movement can result in injuries to the tendon. A NIPI study investigated the impact of collagen peptide on Achilles fibrils in rabbits. The rabbits were given 0.2 grams of NIPI collagen peptide for 56 days, and the collagen fibrils of the Achilles tendon were observed by a transmission electron microscope. Controlled animals were given lactalbumin or water alone. In the Achilles tendon of rabbits that ingested water alone, collagen fibrils of various diameters were seen as observed in the graph. These graphs show that when the rabbits were given low doses of lactalbumin, the collagen fibrils became thicker. However, collagen fibrils were much thicker when rabbits ingested collagen peptide than when they ingested lactalbumin. This suggests that collagen fibrils in the Achilles tendon become thicker, specifically in response to ingestion of collagen peptide. Sarcopenia is the age-related loss of muscle mass, strength, and function. Typically beginning around the age of 50, it involves the gradual decrease in muscle fiber size and number. This decline leads to reduced physical performance, increased frailty, and higher risks of falls and fractures. Factors such as hormonal changes, decreased physical activity, poor nutrition, and chronic diseases contribute to sarcopenia. In a 12-week randomized controlled trial, the efficacy of specific collagen peptides combined with resistance training was investigated in middle-aged, untrained men to improve body composition and muscle strength. 97 participants were divided into 3 groups: those taking collagen peptides, a placebo, or whey protein, with each group undergoing the same resistance training regimen. Results showed that the collagen peptide group had a significantly greater increase in fat-free mass and a decrease in fat mass compared to the placebo group. The whey protein group also saw improvements in fat-free mass and fat mass, but the effects were not as significant as those observed in the collagen peptide group. Additionally, leg strength gains were highest in the collagen peptide group compared to the placebo and whey protein groups. Thus, specific collagen peptides with RT were more effective in enhancing body composition than whey protein or placebo.